Hello friends, this is Zubair Altaf Qureshi. Welcome back to my channel, and this is the part 2 of the VPN sessions that I am having on my YouTube. Okay, and before we begin, just a request: kindly share, like, subscribe my channel as much as possible. Right? So let's see what is the agenda of today's topic, right? I mean video, right? So the topic is like VPNs, as you know, and in the first video, the part one of this VPN, right? I showed you regarding IPSEC, right? That was like one side to another, and then it that was the demonstration of the native IPSECs. That is called the native IPSEC, okay? And these source, like the interesting traffic, is the ACL, right? Now imagine that you have a new branch office, right? Then you have to add that branch office. How do you do it, right? You need to see that, right? Okay, then you will see the advantages and disadvantages of native IPsec and what alternatives we have, right? And then GRE tunnel, right? I'll demonstrate that. Let's see. So to begin with, this is the uh, topology that we had, yeah. And like yesterday I had a tunnel from R1 to R3, right? So let's go to R1. This is R3, right? So let me just map, I mean the resize my windows so that it would be clear to you guys. Okay, so this is R1 and R3. So I'll go and say show crypto ISACamp SA, right? This is the command to see the phase one, right? And you can say show crypto IPSec SA to see the second phase, right? So you can see ISACamp shows nothing, right? IPSec shows you something, right? These are the details regarding the information that we have already given, right? Like the ACL, right? So this is the ACL, the peer address, the port number, because this is ISACamp will be using port number UDP 500, right? And you can see origin is ACL, and actually this is the most important part, right? How many packets were encapsulated? So I said, right, this your ESP or your IPsec, right? It provides encapsulation, encryption, and hashing. This is digest, right? Hashing. So how many packets were encapsulated and how many packets were encrypted and how many packets were hashed, right? Then this is decapsulation, de-encrypt, and again verify, right? So this is very important. So as you should see, like if you have 10 here and you should have the same number here, that means that the encrypt and decrypt is having no problem. So if you have any problems here, you can look for two things. One is routing, second is the ECL. You have to check those things first, right? And then you can see these inbound and outbound like uh, SPIs that we say, right? These are actually the this would be the opposite on the other side, because if this is the outbound, here the same will be the inbound SPI, right? So SPI numbers I will explain to you later on in this session. Why do we need those? Okay, so let's go and let's check in R3 also. Show Isaac and show crypto ISACamp SA, right? So this is the first phase, nothing, right? Then IPSec SA, so you should see something, right? Same, but this will be the reverse, right? So 10, it's showing 10.3. So here it's 10.3 on top, reverse, right? And then this is the peer, and again nothing, right? So let's ping and see this traffic, and the encrypt and decrypt counters will be increased, right? So you say ping from 10.3.3 to 2333 from source of your loopback 0, that is 111. So this will initiate the what do you say, the traffic, right? So I'm pinging from 10 to 1033 from 10.111. But before that, let me just see if this is enabled. Yeah, this is okay. Let me check my routes. Okay, let me ping my next hop, that is 10.1.12.2, right? This is that, and then let me check my interface of R3. so I'm able to reach. Let's try once again, because that was the first ping, so maybe packets were lost in between because of R, but no, there is some issue. Let's see what is the issue. Okay, and that's good, right? We will get to troubleshoot. So let's see if my IPSEC amp, right, is uh, show crypto IPSEC amp SA, right? So let's see. Yeah, so I can see it's idle mode. That idle mode is good, but then I see active. Let's see IPSEC SA, right? So I cannot see encrypt and decrypt. And let's check the ACL, show access list. Is it getting hit? Yeah. So I have two access lists. So oh my, so I need to uh, go to my running config t, and go to what is that access list one. So how do you do it? IPX in access list, right? In the extended access list, you can just go on and delete the lines, right? And say no 20, right? I don't want that. And and try. So let's see the running config. You can say so section crypto, and then I want to see access list also, and I want to see key also. Right. So these are the, this is the command wherein we see all the details of the your policies and the key and the transform set and the crypto map, right? Crypto map, I can see there is something missing in crypto map. Let's try that config t and go to this crypto map. I don't see my transform set being called set transform set key set, right? Let's see. And I want to see my show running interface Ethernet 0/0. So that is my this, yeah, crypto map has been applied. Let's try the ping once again. 10.3.3.3 source of loopback 0. And okay, now that is the one. Yeah, so I have the ping. Maybe that t set was not there. So let's try again and again, and now I'll see the crypto uh, first IPSEC amp, the phase 1, right? I say, and that is the same active, because the phase 1 was getting negotiated, I think, and the problem was in phase 2 because transform set, because of transform set, right? So when do we exchange the transform set? It is on the 7th and 8th packet, right? So anyways, now let's see show crypto IPSEC SA, the second phase. So here I should see some encrypt and decrypt, right? You can see 14 and 14. I sent 15 packets, 555 pings, right? But the first one was lost because of ARP, so that's why that is the case. So here also, if we see IPSEC SA, right? So okay, show crypto IPSEC SA, right? So I can see 14 here also. So these are the things, right? So if you have inbound, just check the this thing, inbound ESA, right? ESP number, right? SPI number, sorry. So this is the 0x5C5, and just let's check this on the, so if it's inbound here, it should be outbound, right? So you can see not in the inbound, we'll see on the outbound. So do these two match? Right, these two match. So that's what I'm saying. So from here it gets encrypted with this, and here it gets decrypted with this, right? So that is what it is. And then the mode is tunnel, right? I'll show you what this does in the upcoming video. So my job in this video is to create a tunnel from here to here. Okay, so this is say this is my new branch office, right? So I want to connect this to my hub, right, or my head office, right? So let's grab my pen, right? Okay, so I grab my pen and say we already have this this IPSEC tunnel between R1 and R, this one, right? R1, and so we have a IPSEC tunnel here. Now what I'll do is I want this IPSEC tunnel from R4 to R1, right? So again, they will have this IPSEC amp tunnel, phase 1, right? Phase 1, and then they will have their phase 2 also, right? Phase 2. So let's do this, right? Just like, okay, let me just load this. this will be an exercise of yesterday's lesson, right? But then again, you will learn some new things. Okay, so let's grab my notepad and see what we need. Step one was what? Step one was the phase one policy, right? So I'll do this, and this is for R3. So I'll take this up, okay, and then this is for R3, right? So step one is what? Configure the phase one policy. You can say IPSEC, right? IPSEC policy, IPSEC policy, right? So that is like, how do you write that? Crypto IPSEC policy, and the number can be anything. This is locally significant, and then you say encryption. Just remember, the same should be on the other side. Encryption, and this time we'll go for 3 days. Hash will be SHA, okay, and then we have authentication, that is authentication, right? Or you can just say authent, and then it will autocomplete. Authentication is pre-share, right? Pre-share, and then we have what? Last one is the group, right? So I'll be using group 2 here. Okay, that's done. Step 2 is what? Step 2 is the authentication key, right? The pre-share key, I will say pre-share key, with the next the pair IP address. So how do we write that? Crypto IPSEC key, right? For this one, I'll keep a separate key. So that would be what? Key R4 to R1, right? R4 R1, right? So R4 R1, okay, and then address. So I'll give you the public address of my peer, that is 1.150.1.12.1, right? That is the public IP of R1. So that is the crypto IPSEC key. This and the address. Okay, fine. And then the third one is what? The transform set, right? Third is the phase 2, right? Configure phase 2 policies, right? That is the what? Transform set. Transform set. Done. And then the transform set is written how? Crypto IPSEC, right? Transform set, and then I'll be naming it T set. So what I can do is I can use that T set that I already have, right? So let's use that one only. Okay, so I keep it there. I don't need to configure because I already have this. If I go to this, I can see I had a show running config, right? So I did this show running where okay, yeah, so I can see I have this, so I don't need to like specify one more if I am going to use this. So I'll be using this T set only. After that, what you need is an ACL, right? So number 4 is what? Interesting traffic. Interesting traffic using an ACL, right? So what's the interesting traffic for? Traffic from R1 R4 to R1. So this is for this is for R4, right? Not R3. R4, right? So interesting traffic from R4 to R1, right? So it's access list. So 101 I already have, so I'll go for 102. Permit IP 10.4.4.0, then the wildcard mask 255, and then the destination address, that is 10.1.1.0, right? Okay, that is the access list, right? Fine. Now the fifth one is the crypto map, right? You have to call all this into one crypto map. So crypto map, you have already one crypto map, and you can only have one crypto map applied on a particular interface. So there we have only E00, so we cannot apply another crypto map, but we can have another sequence, right? Like the ACL that we have, right? The sequence number like that. So we can do crypto okay, crypto map. The name was C map, right? So I can see here, right? Then the number, right? So that was 10. This, for this I'll keep 20. So this will be a separate crypto map as the cap, right? This case. So here I set peer for me is what 150.1.12.1, right? And then match address is here it is 102, right? And then okay, here I can say 101 also on R1, but on sorry, on R4 I can say 101, but on R1 I have to specify as 102, right? So this ACL number is locally selected. You don't need to match this ACL number. Then also you can say your I have done the set up here, right? And I need the set transform set is, I think it's like this. So T set. So for this I need actually this one, right? T set, right? So this is for actually for your what? This is for R4, no? So I need this cryptology. But for R3 I don't need it. So after that what you do is 6 apply this on the interface, right? 6 okay, interface ETH0/0 crypto map C map. That's it, done, right? So that's correct, right? So let's go and copy this on R4, right? Copy and paste. Do I have R4? Oh no, I don't have R4. So let's go to R4. So we'll see on R1 you have two tunnels, right? You will have two tunnels because it has one with R3 and one with R4, right? So that is what we do. More. And what about R1? What do I need on R1? Okay, I need this policy. Okay, enable conf and the host name is R4. Okay, and then I'll go and paste this first. Let's hope that I have not done any spelling mistakes or yeah, I can see. So 5. Okay, this is wrong. What I need to do is this and 5, right? So I would go here. So access list is fine, and I'll go here and type this. Again, there is some problem. Set here. Okay, my mistake. Let's go do again. What is crypto map C map? Crypto map C map. I think that's right. Let's see this. I go exit, and then like this. No, again it doesn't work. So I'll go exit. Let's type crypto map C map. Okay, then I need the policy number. IPSEC as a camera, right? That is fine. Then why wasn't this taking this command? Anyways, so next is this set address and then the interface. There I apply the program. Done. Once I say this, it should say your Isaac camp is on. Fine, nice. So I'll end this and I'll write down the configuration and see my show crypto. My phase 1 will not be there. Let's see the phase 2. Right, SA, and I can see I have the ACL 4 to 1, right, and my peer is this, and ACL is the origin, right? Nice. So for R1, right? So R1 has some policies. So if I go enable show run section, okay, show run. I don't want this show run section. I show run pipe section crypto, then pipe section access. I want to see the access list, and I want to see the key address. So these 3 should match, right? So if I go here, show run section crypto again and access. Okay, I'll do this access, and then I need key, right? So these are the things that I have. So let's see the policy that it has, right? It has crypto policy 10, but it will not match, right? So I need the same policy there. So this is 30, right? So I'll go here 50. So let's write down here on R1. R1, right? What do I need is this policy. So encryption is there, authentication is there, and the hash, right? What was the hash? I think I used SHA. If I go here again, 150 and I go to the policy and say hash I use SHA, right? SHA what? SHA, right? Yeah. So I used SHA. There also I use SHA, right? So this doesn't need to be the same number. So let's go for 40, right? Yeah. I okay. So anyways, let it be 30. And this number doesn't matter again. That's what I wanted to explain to you. Anyways, keep it like that. Then comes the what you need. The phase one policy is done, and the uh, key, right? I need the key, right? So crypto ISACAM key, right? Then I have which one? I have this key, right? So I paste it here, but the address here will change, right? So it will be 150.1.2 to 4.4, that is 24, right? So that is my next hop, right? And then comes the ACL. So if I see here, do show run, okay, do show access, right? Access list, access. I have only one access list, right? And that is 101, but I need another access list 102, right? Permit IP from 10.1.1.1. So let's do 10.1.0 from 0.0.0 right? That is 255 going to where 244, right? 10.4.4.4.0, right? 0.0.0.255. So that is my ACL. That should be the mirror of this ACL that I have here. So if I see access list, I don't see access list. Do show run. No, do show access list, right? I want this and this on R4 what we have, right? This on R1 it should be the mirror image of that ACL, right? Reflection of that. That is called the reflexive ACL. But this is like done manually, but we can do this like dynamically also using reflexive ACL. Anyway, so that is that. I have the access list. After access list, what comes is the crypto map, right? So I have this crypto map 10, but here I need to have another crypto map, right? This one, I will do one thing. I will just copy this, and crypto map should be 50. Okay, IPSEC ISACAM. Okay, done. So I'll set what address? No, I need peer. Peer for this is 150.1.24.4, right? Yeah, and then match address should be my 102. Okay, and then uh, set peer match address. What is that transform set, right? So I'm keeping the same key set, right? So transform set is same and applying to the interface because that is already it's on the interface. If I go and check it's 00, it's already applied, so I don't need to apply this. Now let's check how many show crypto IPSEC essays I have on R what do you say, one, right? So I have this one which goes from 1 to 4. That is the one that we are. So for this I should not have any what do you say, inbound and outbound SPIs, right? No, not there. So this is the one to from R1 to R3, right? Nice. Okay, fine. Let's ping. Let's ping from 10.4.4. Yeah, 4.4 from the source of loopback. From the source of loopback 0. If I do loopback 1, this won't work, right? Because I'm not hitting the ACL, right? That is the interesting traffic. So let's do. We need to understand that. So let's do this. Source of loopback 0, and let's see where we are facing issues, right? So let's check the problem. What is the problem? So let's check the ACL first. Show access list, right? So there are 10. Oh my god. From 10.1.1 to 10.4.4, I have 10 matches. But I did only 5 ping. 10.1.1.0 going to 10.4.4.0 on that address, and from here. Anyways, let's check the ISACAM essay. Right? That is the phase 1. So for no state, no state. So you need to understand this no state. No state means that I am facing issues with the policy of phase 1. Okay, let's check. Show run show run section of, okay, let's go here, section crypto. Let's check the policies here, how many policies I have, this and this, right? And if I check here and show runs section crypto, how many policies? Only one. So what happens is when I initiate from R1, right, it sends both the policies to R4, right? R4 checks what matches his what policy in his configuration matches anyone, right? So for him it should match with policy 30, right? So let's check on, okay, let's go to our Wireshark, right? Why not capture this packet and see what's happening, what's being advertised, right? And where we are facing the issues, right? So I can see the packets, right? But maybe in obviously in the corporate network, right, in the real world, you may not have access to this Wireshark, right? So you can go with the no state and all those stuff. I'll show you all the states and what does it mean, right? So let's do this once again, that thing, right? So that it will initiate the traffic. So this is a thing that I want, and I should see some. So see, you can see. So packet 1 is going, and I'm not seeing any packet from the main node. The packet 2, I told you that we're facing issues with the policy, right? So that should be in our this one, I think, yeah, or the policy should be here in the payload security association, yeah. Pay proposals, I have two, right? So which one is that? Payload proposals, I have two. Next payload payload proposal is this one, and transfer, okay, I have this one. So this says what? So let's see here, right? So this says, oh, okay, I can see the number. No, I don't see the number here. Anyways, this says days. So if you see on R1, right, it has which one? These two, right? These two. So here if I say, oh my god, where did this one, right? Okay, let's check. Policy 1 is hash MD5 pre-share group 2, right? This is MD5 pre-share and group 2, correct? And the second one, I don't see the, like, it's not in the running, but it is there, des, we are using des. And the second one should be 3 des, right? So I'll close this, and the second one should be 3 des, right? 3 des and SHA, right? I use SHA, and then I have the pre-share, right? But why isn't this replying the other side? Let's close this, and let's do one thing. Let's do capture on this, right? Let's do a capture on E00 and initiate a ping from this side. So I'll go for R4 and ping 10.1.1.1 source of my loopback. Do I have the loopback? Let's see. So IP interface. Oh my god, I have no loopback. So that is the issue, because there is not even the loopback. I don't have any interface IP. Oh my god. I did configure, but anyways, let me configure it quickly. Show IP interface. Okay, interface key 0/0. That's what I was thinking. Like IP address 150.1.24.4, right? And then 255.255.255.0. No shut. Interface loopback 0. IP address 10.4.4.4. So there should be a space here, and I need the mask, that is this interface loopback 1, right? IP address 10.1.4.4. So that is done, and show IP interface brief. Yeah, right. Now let's check the same thing. So I am monitoring this one, right? So I should let's see what I receive from this side if I do a ping from R1 again. So this is the ping, and let's see what I receive. Identity protection. What was that? Okay, I should have. What did I receive? This is from 1.1 to this. Okay, so I received the first packet. Okay, so I should have some association, right? Yeah, I can see. I have a proposal. Like two proposals, right? So these are the two proposals. So packet one I see, but what I sent is not seen. So let's stop and let's do one thing. Let's see all the packets, right? So what I will do is clear crypto ISEC amp SA. I think this is clear crypto ISEC amp, yeah, and clear crypto IPSEC is there, yeah. And then IPSEC after that should be no, I don't want that, or I can say sessions, or I can just say SE. Done. And I'll do this on R4 as well. Clear crypto SA, clear crypto sessions. Done, right? So let's go on our, even if I capture here, what I can do is what I'm saying. So you have seen, right? So I'll be sending what all policies I have, right? Then this guy will be, what do you say, uh, choosing the one that matches the policy that is inside its configuration, right? So let's go on R4 and let's ping to R1 and see this tunnel coming up. So 10.1.1.1 source of feedback 0. So that is my ping and it should go. No, it's not going. Okay, let me check the configuration again on R4, right? Good. Show run interface ETH00. Do I have the crypto map? Yeah, I have the crypto map. So do I have the route? Yeah. So for this I need default route, right? First of all, I should be able to ping 150.1.2l.1, right? So that is the most important part. I should I mean I should be able to reach this interface, but I'll not be able to reach this because I think I don't have the default route, right? So I'll configure the default route that is needed also for the tunnel, right? So you can have a static route also for this IP, but mm, in the case of lab, right, not in the real world. Because in the real world, you cannot have a route to that. What do you say? Private IP. Anyways, and then I'll go and say IP route 0.0.0 0 dot oh my god 0.0 and 0.0.0. Next hop is what 150.1.24.2. So done, right? So that should be the last thing that was missing, right? So good, we are having a good so I have the ping, right? You can see my echo request is going like that, and it is 11114, right? This is ICMP, right? So ICMP works on the network layer and then comes to your IP header, right? So this is 114 bytes. Let's see when ESP is attached to this, what's the size then, right? We will be paying some price for the security, right? So let's ping 10.1.1.1 source of loopback 0. So this should go. Yeah, I can see the ISAC amp policy. This what do you say, negotiation happening, right? Packet 1, 2, 3, 4, 5, 6, 7, 8, 9, and the quick mode is done. Let's see this one. So from 114 to 166 bytes. So underneath you cannot see anything, right? So that is that. And now if the problem is, right, the problem is, so you can see it becomes cumbersome, right? Now you have added this four side. Say tomorrow there is a new site, right? What do you say, this I have a new site, say R5, right? I connect R5 to this ISP, right? Then again I need what? I need a tunnel to this. Now for example, we have a tunnel to this. I want a tunnel to this again. So it becomes cumbersome and it's not scalable, right? In this sense, it's not scalable, not scalable. And the see, if we talk about advantages and disadvantages, first of all, the one that I'm going to say right now, the point, right? It you can take this as an advantage as well as disadvantage. So being static in nature, right? In the sense we have the ACL, right? That is the source of the tunnel, right? For the encryption traffic, right? So that is the uh, what static in nature, right? So like this can be taken as cumbersome, correct? And because you have to do this configuration manually on each sites, right? The more the sites, the more the configuration, right? But in other sense, you can say it's more secure, right? Because you have control over it, right? So you have that control. It's more secure also, and that is that is something which doesn't matter that much. But that secondly, the biggest problem is we cannot run the dynamic routing protocols, huh? Right? So some people say that it doesn't support the multicast address. It does support multicast address, but the problem is, just think about the interesting traffic. Interesting traffic, right? So you need lots of ACL. So for example, you are running your what do you say, EIGRP, right? So you are running your EIGRP, and just imagine the ACL that you write. What would be the ACL? Let's just think from one side, from our first perspective. So ECL would be what? Mm, source would be 10.4.4.4 going to what? 224.0.0.10, right? That is fine. That is fine. From here, it is fine. So you would have many ACLs anyways. But let's just think how we can do it, right? Uh, what would be the return traffic? It should be a mirror, right? Mirror of that ACL. So how can be the ACL source 224.0.0.10 going to that destination 10.4.4.4? But this cannot be done, right? Because traffic cannot be sourced from a multicast address. No. So there lies the problem, right? So if I want to run routing protocols between these two sites, we don't have that option here, right? So what we do is, instead of this, we go for other options like DMVP and IPSEC over GRE, right? So we have discussed the advantages and disadvantages. So that's why we go for alternatives, right? So let's see what GRE tunnel is, right? Okay, for that I'll just pause my video and I can just set up my this or else I'll just do it quickly and stop these routers, and I'll close this. I'll create a new lab saying GRE. This will be the basic GRE. Okay, save. Again, I'll need how many routers? Three routers. Yeah, same thing. R1, R2, and R3. Okay, save. Okay, I just did what? Only two routers. Node IOL. This should be L3, and I need two nodes more. Now that's done. Now I'll keep this here, and this here. So what? This is the ISP. Okay, I'll change the what we say the sign, right? So this should be cloud. Nice. Save it. So I'll connect this to my ISP, and then ISP goes to my other side, right? So again, let's do one thing. I need some shapes. I need a square. Okay, fine. I'll just keep it here. Okay, I'll make a duplicate of this, which I'll keep here, and then I need the IP addresses. So this is 151 151.12.1 this side, right? Okay, I'll keep this like this. Fine. This is my this thing. So likewise, you know that R2 is dot 2 and R3 is dot 3, right? So this is my 23, right? 2 3 23. And behind this I will have some loopbacks. Okay, 10.1.1.1. this is dot 1, okay, and I will have 10.1.2.1/24, fine. And then I will have duplicate of this on this side also, and then I can go inside and say let's do this 10.3.3.3, that is fine. And let's do 10.1.3.3, so that is fine. And now what I'll do is I'll configure these routers, okay. Okay friends, so I have configured this R1, 2 and 3. So I have also configured not a default route, I will configure it static route, because in here I need connectivity from R3 to R1's external IP address, right? That would be your public IP address. Okay, let's see what happens with the traffic. So for example, I have show IP interface brief, right? So when I say ping ping what? So I have to see show IP route. Show IP route, right? So what all routes I know? I know 10.1, I know 10.1.2, I know 150.112, I know 150.26. So let's ping this 150.23.3, right? So when I do this, okay, 150.1, right? So when I do this, what happens? What happens? Let's see. Just to understand the packet level, right? On R1, right? You say ping what? 151.23.3, right? So that is R3. So what happens is this, he checks the routing table, right? He finds the exit interface and sees that this is reachable via this next hop, and does a recursive route lookup and finds 1.12 resides where on this Ethernet 00, right here. So he pushes the packet on that interface, and the source is what? The interface IP, right? The external interface IP, that is 151.12.1 going to 150.1.23.3, right? And then this packet reaches out to say show IP route, right? Again, it checks the route, it's directly connected, right? 23 is directly connected, and the exact interface is this. Does what? Does the layer 2 rewrite and then forwards the packet to R3, and R3 like has this IP address on its physical interface and replies back with the ICMP echo reply, right? This was echo request, it replies back with the echo request. That's how it is, right? But now what I want to do is I want to communicate between these two, but I want to use routing, not ACL. I want to use routing. And then whether it be static route or a dynamic routing. Let's see how GRE helps us in this. GRE is very easy to configure. What we do is we go to this router, right, and I say interface tunnel. This is basically a tunneling protocol. So say tunnel 10, anything you can say, locally significant. Okay, then you say the IP address. So for this you will have a, so what you get is a point-to-point connection between these two, right? So you can assign any like private IP address 192.168.1 dot say 0/24. So yeah, so this one will be 1, this one will be dot 3. So I say this one as 192.168.1.1. So this side is 1.1, right? And then what you say is the tunnel source and destination. So first one is interface tunnel, right, 10, and then add IP address of that interface, right, 192.168.1.1, and then you say what? You say the tunnel source. So this should be your if you're giving IP, so here you have option, you can give the exit interface as well as the IP address, but IP address should be your public IP address, right? So I can say either 0/0, or I can say this IP address, not this one, the 150 also. Okay, 12.1. I can say this, both, like one of this, and then you say the destination, that is the peer IP address. So that should be the IP. You cannot give that as a this interface, right? So that is my 151.23.3. So that's why you should have the eligibility from your public to public, right? And then likewise we can do here. So this is a tunneling protocol, right? How, what do you mean by that? It's like it tunnels this traffic through, it literally creates a tunnel, and it bypasses this R2, right? R2 doesn't even know what is happening. I mean, it doesn't look into the inside traffic, right? It just uh, forwards the packet looking the outside header, right? So if I just describe this in that sense, what happens to this is when I configure this interface on both sides, then I ping, right? Then I ping saying 10.3.3.3 source of loopback 0. So for that you should have route on both sides, right? Loopback 0. What you do is you say this, and what happens is you generate a trap this packet, right, going to 10.3.3.3.3, and this is this, and the source is your 10.1.1.1.1, right? Fine. On top of that, what happens? You get encapsulated by GRE, and GRE attaches the public IP header on this 1.12.1 going to 150 1.23.3. So that will be the structure. We'll see the structure, right, when I configure everything. So let's do this. Let's begin the configuration, right? Then we'll see this on our Wireshark. So what I do is interface terminal say 5 IP address 192.168 1.1, right? Then I say tunnel source is my Ethernet. I can say this, right? I'll say Ethernet, and I'll say the destination, tunnel destination is 150.1.23.3, right? So that is done. That's done, right? Now when you see show IP interface, you will have a tunnel interface right here. Tunnel 5, but what happened to the IP address? Did I say IP address? Okay, I didn't give the subnet mask, right? So interface tunnel 5 IP address 192.168.1.1.255.255.255.0. So that's done, right? Show IP interface brief. You will see the IP. You can ping this IP address also. So if you ping this like this .168.1.1, right? You can ping this. So likewise, I'll create here 150 interface tunnel. So I can say there I have made what 5, right? I'll make it 10 here. IP address 192.168.1.3, right? 255.255.255.0, and then I will say tunnel source. I'll say the IP address here 150.1. I want to show that we can do this both, right? Then tunnel destination. Tunnel destination should be always IP address or the public IP of your pair, right? 12.1. So that's done, right? Show IP interface brief. You will see that. Now let's see what I do. Can I ping this 192.168.1.1? Will this go? And if it does go, what will the packet looking like, right? So let me just show you, and then we'll see, right? So now what I'm doing from R3, right? From R3, what I'm doing, I'm pinging what? Ping 192.168.1.1, right? I'm not giving any source, right? So what happens is it goes to my, it checks what? Okay, when I do show IP route, goes into the route and says show IP route. I have this, right? So what I do is show IP route. So I have a packet, right? That is destination 192.168.1.1. The router always looks the destination IP, right? So when I check this destination, it does the route. How can I reach this address? So it says this address is via tunnel 0, right? Via tunnel 0. Then it says, okay, if it's via tunnel 0, then I need to check the tunnel 0, right? What is the running configuration? So run tunnel. Okay, I have to specify like this. Tunnel, I think that is 10, right? Yeah, tunnel 10. It literally goes into this interface, right, and checks. Okay, let me grab this. Erase this. Fine. He checks the tunnel source. What's the source and what's the destination? So here it will give the source as this thing 150, 123 and 3, right? But this is the internal header. So for that you go for the tunnel IP 192.168 1.3. So this is the one, and then on top of that it will say GRE and then the external IP address. So from here you will take the source and the destination. Source is 150.1.23.3 going to destination 150.1.12.1, right? So that is the IP address. That's how it is. Let's see what I have in the what do you say, the Wireshark, right? Ping 192.168.1.1. So this is gone. Oh my god, I should have captured, right? Anyways, I'll capture now and we'll see. See the problem. I mean, like, there's no problem actually. I don't want my videos to be so long and boring. So what I recommend you guys is to increase the speed of my videos because I don't tend to talk much quicker, right? I'm very slow in that. So if you just increase the speed, that will help you. So that's the ping I'm doing. So I want to see the echo request. So what I said is this one, right? So let's just see. So the ICMP is there. Okay, so this is ICMP here. Yeah, the data then goes the inside, right? You can see that is the header here. This is the header, right? And then I have the GRE, right? That is the GRE, and then I have the external IP, that is this one, right? So this is the header, right? This is how your header looks like. And now the actual thing that I want to do, that's why I have used this. Now if I can do this, I can also do this IP route, right? IP route 10.3.3.0 via 192.168.1.3. 1.3. Nice. Okay, I don't have to write this wildcast mark. This should be subnet mask 255.255.255. So that is the one, and for the return also I have to have a route here, IP static route, IP route 10.1.1.1.0.255.255.255.0. Its next hop is 1.1. So I have literally a point-to-point connection, right? So let's do this and let's do a ping. Do ping 10.2.3 source or loop back 0. And yeah, this ping is going, right? So how is the traffic? It is again the same thing, internal header and then the GRE encapsulation and the public header, right? So that is how it is. Let's check again. I'll go to R1 and do the ping again. You can see, right? Echo request, internal header, ICMP, echo request, right? Going to this IP header is applied on top of it, right? 10.1.1 going to 10.3.3. Then I have the GRE header and then the external header, right? So that is your GRE tunnel. Last thing is the routing. So now if I can do this and I can do this and this done, right? And then config t, and also on my R3, right here I'll say no, and then this one. Nice, right? Now what I can do is I can run the routing protocol, no auto summary, right? And the network 10.3.3.0 done, right? And then also I can run this one, done, right? And right now if I go here, router EIGRP, what? Router EIGRP 10, no auto summary, network 10.1.1.0 0.0.0 and then the second one also. That is what I have run on the internal interfaces. What about the external? Do I run this on the public or the tunnel interface. Just imagine. So my traffic should leave from the tunnel interface. Then only this will be encrypted with, or sorry, encapsulated with the GRE. So remember, GRE does not provide encryption. Okay, it does only provide the encapsulation. You can see the packets were open, right? It was not encapsulated with any ESP or something, right? GRE, just to understand, it's a tunneling protocol, which provides encapsulation only. Okay, now for the external, I'll say 192.168.1.0, right? 0.0.0, or you can say 1 and then 0.0.0. You can match exactly this thing, and I can say here also router EIGRP10, the network 192.168.1.3, right, and 0.0.0. So I'm matching the okay, and you should see a neighborship up. Yeah, you can see the neighborship, right? So the neighborship is going. So the neighborship is up. Sorry guys, I'm having this cold, right? So E00, if I go, I was actually running this, right? I think, yeah. No. Okay, now I can see the hellos going on, which will be encapsulated. So you can see IGRP hello, right? So this is the hello packet, then the inside header going to 2440010, right? Then the GRE, then the external. So that is how you can do. Now you have what? You have the reachability, right? So if I see here, show IP route, I have learned 10.1, 10.1.3 and 10.3. So I can ping, right? So I can ping 10.3. Okay, 3.3.3, right? Even with the source of anywhere, loopback 0 or loopback 1. So this is where it helps us. But then the problem is, this is all clear text. You can see, right? I can see ERJP packets, I can see ICMP, everything, right? So we can make this secure, right? That is the next thing, that is called what? That is called your IPSEC over GRE. So for that you have to watch my next video, right? That will be in my next video. Okay, so you know how you can create the profiles, right, for IPSEC phase 1, phase 2, same thing, but let's see what's different in this and that, right? Okay, so for that you have to watch my next video, and if you like the content, right, don't forget to subscribe, share and like my videos. Thank you guys, that is it for today's video, and bye bye and happy learning.